Alright, welcome back, guys. I'm going to try to get a little closer to the microphone so that you can hear me without having to turn the volume way up. Anyway, we're going to look at section 1.2 today, so this is kind of a continuation of 1.1. So with 1.1 we looked at sort of a definition of statistics. We try to develop a feel for what it actually is. So we know it's a science of collecting data, organizing data, and letting that data really tell us a story. And then using that to be able to make decisions. We looked at what a population was versus what a sample is. We talked about what a parameter is versus a statistic. So remember, parameter pertains to population, and then a statistic pertains to a sample. And then lastly, we looked at descriptive statistics as opposed to inferential statistics. Okay, so descriptive statistics, they describe or they paint a picture of what the data is trying to tell us. And then inferential statistics, we're really looking at that data and trying to use that data to make decisions, okay, to inform us. All right, so today we're going to look at data classification. And so our learning objectives are going to be how to distinguish between what we refer to as qualitative data versus quantitative data. So remember, data is really what we're interested in, right? And then secondly, we're going to look at how to classify data with respect to 4 levels of measurement. And these are going to be the nominal level of measurement, ordinal, interval, and ratio. And we'll talk about these in greater detail. So the first thing here is there are 2 types of data, okay? The first is qualitative data. And when I see qualitative data, guys, I think about the word quality, okay? So we're talking about qualitative data. We're talking about something that is in most cases not numbers. So for example, attributes, labels, or non-numerical entries. Okay, so again, like I said, you want to think quality here. So qualitative data is any information other than numbers, although it can actually be numbers, and we'll see some examples of this. So you want to ask yourself, if I do a mathematical calculation with these numbers, is it going to make sense? Okay. And if the answer is no, then it's going to be qualitative. So an example would be like your student ID number at the college or your social security number. That is qualitative data, even though it consists of numbers. Those numbers are simply labels. Okay. Here's another example. The numbers on a player's jersey, okay, those are numbers strictly used to identify that particular player. So that is qualitative data, even though it is numerical. Let's see, what else? Typically, qualitative data is going to be like, you know, what's your favorite color, or what's your favorite flavor of ice cream? Here's some other examples. Names, cities, TV programs, ice cream flavors, models of cars, okay? All right, and then we'll contrast this with quantitative data. So with quantitative data, you want to think about the word quantity. So quantity refers to a number, okay? So quantitative data, this is probably what you typically think of when you think about data. It's going to consist of data that's either measurements or counts. Okay, so here's some examples. The prices of cars, the ages of your family members, the income of employees, temperatures of a city, the number of pets in a household. So this is all numerical data. And furthermore, a lot of this data we can actually do some mathematical computation and have those results make sense or be meaningful. Okay, we'll talk more about this here in a minute. All right, so here's an example. I'm going to zoom in a little bit so you can see this. So what we've got here is a compilation of some data, and we actually have both qualitative data and quantitative data in this table. The qualitative data would be the different species, okay, these different either vulnerable, endangered, or critically endangered species, depending on how they're classified. Okay, so the African elephant, black-footed ferret, etc. So on the left-hand column, we've got an example of qualitative data, and then in the right-hand column, we have an example of quantitative data. So you can see this data consists of the actual number of species of animals, okay, for each of those given species. All right, so now we're going to look at some examples on our own. So we're going to determine whether the data here is either qualitative or quantitative. So number one, it says the weights of dogs at an animal rescue facility. Well, the weight of a dog, guys, is a measurement. It's a numerical measurement, so this is going to be quantitative data. We could perform some operations, right, with that data. So quantitative. So again, remember, think of quantity. Number two, the carrying capacities of flatbed trucks. Okay, so the carrying capacity, guys, is basically how much can that truck tow. So this is going to be a measurement of weight. So, for example, you know, if it's a half ton is 1,000 pounds. So it's a rating, it's a measurement. So this is also going to be quantitative data, okay? Now, we don't actually know what the data is, but if we were to collect the data, it would be quantitative in nature. And number three here, hair colors of classmates. Well, this is qualitative, okay? This would go back to, if you look at, come back up here and look at the definition, what it means to be qualitative data. This is an attribute, okay? Somebody's hair color. All right, so this will be qualitative. Okay. And then finally, student ID numbers. Now you would think, okay, well, these are numerical or these are numbers, so it's got to be quantitative, but it's not. Like I mentioned earlier, these are basically attributes or labels, okay? These just define who the specific student is. So if you look back here, where was it? Well, sort of like the baseball player's jersey number, okay? That is qualitative data, even though it's numerical. So anyway, this last one, student ID numbers or social security numbers or anything like that, that's just qualitative data. Because it just really identifies. Okay, so qualitative. All right, so you'll have a few questions in which you have to identify the type of data, be it qualitative or quantitative. And now the next thing we're going to talk about, the next and last thing in this section, guys, is the level of measurement. So we've seen these two different types of data, or that we can have data and we can classify them as either as qualitative or quantitative. So now we want to go a step further. Okay, and another characteristic of data is going to be what's called, or what we refer to as its level of measurement. So what this basically tells us is, if we've got some data, what can we do with it? Okay, if I have two data entries, can I subtract them, one from the other? And if I can, is that difference meaningful? Or can I say that one data entry is twice as large as another data entry? Well, with some types of data you can, and some types of data you cannot. That's what we're going to look at next, is really the complexity of the data. Okay, so guys, if you look here, there's going to be 4 levels of measurement. And the lowest level here is nominal. When you see that word nominal, guys, think of in name only, okay? So well, actually all pretty much of qualitative data is going to fall under this lowest level of measurement, nominal. And then we've got ordinal. So when you see ordinal, you want to think of order. So if you have some data, and really all you can do with it is just put it in order. Okay, but that's a little bit more complex than nominal. And then the next one is going to be interval. So with interval, and I guess I'm already describing these before I'm getting to it in my notes, but that's okay. With interval, not only can you put the data in order, you can actually subtract the data. And those differences can be meaningful. And then finally, the most complex is ratio. We'll look at this here in a minute. The next thing we need to talk about is something called an inherent zero. Okay? So if you have a data set, or if you have a collection of data, and maybe you don't have a value of 0 in the data, but if you did, would that 0 represent a lack of whatever's being measured? If it is, or if it does, that means it's an inherent 0, okay? So I'll give you an example. If we were surveying individuals and we were asking, what is your household income? Some households might be 50,000, other households, 20,000. Other households maybe 80,000 or over 100,000. Okay, so you probably would never get a data value of 0. But if you did, 0 would literally imply that there is no income, okay, or that there is a lack of what we're measuring. So that's an example of what it means to be an inherent 0, okay. If the 0 means none or a lack of whatever we're talking about. So here's some examples. Person's income, okay, the number of dogs that a person owns, right? Because if you have, 0 in that sense means you have no dogs, so a lack of dogs, right? One that tends to be confusing for students is temperature. Temperature does not have an inherent 0. It can have a 0 in it, but that 0 is not inherent. So you may be thinking, oh, well, why not? And the reason is because you have to think about what temperature measures. Temperature is a measure of heat. Regardless of what scale you're using, either Celsius or Fahrenheit, the temperature outside could be 0, but that does not mean there is no heat in the air. Okay? Now, it's not hot outside, but there is still heat because heat is just molecular motion, okay? Motion of molecules that are in the air. So temperature does not have an inherent 0, so you need to be careful about that. In fact, guys, if your house has a heat pump, heat pumps operate on the fact that regardless of how cold it gets outside, there's still heat in the air. And heat pumps actually extract that heat from the outside and they pump it into your house in the winter. Okay, we don't see a lot of heat pumps here in the South. Well, actually, we probably see more in the South than we would in the North. I actually have one, so they're very efficient, by the way. But as the temperature drops outside, it's difficult for heat pumps to warm your house because although they're extracting heat from the atmosphere, there's less heat to be extracted as the temperature drops lower and lower and lower. Okay. Anyway, some extra information there, but all right. So let's look in greater detail at some of these levels of measurement. So, like I said, most basic level of measurement for data is going to be the nominal level of measurement. And this is really for qualitative data only. Okay? So things like names, labels, qualities, you can't do any sort of mathematical calculation with this type of data. And here's some examples. So your favorite color, a person's religion, a person's political party affiliation, all of that is examples of data that's at the nominal level of measurement. Here's some other examples here. Favorite type of music or genre of music, different cities. So this could be, the city in which you were born or the city in which you currently live. And then members of a math club. Okay, so this data here is just simply names. We can't do any sort of mathematical operation with any data like that. So that's data at the lowest level. And then we've got ordinal data at the ordinal level of measurement. So this is a little bit more complex. We can actually do some stuff with it. So this, you need to know, this can be either qualitative or quantitative. Okay. But what makes it ordinal is that it can be ordered or ranked. But the differences in the data entries are not meaningful. Okay. So here's some examples. You could do a survey asking people how afraid are they of heights, and they could list, these could be the choices: very afraid, somewhat afraid, not afraid at all. Okay. Well, if these are the responses, and this represents the data, this can be ordered, right? So this would be, even though it's qualitative data, it is ordinal. Furthermore, person's social class, be poor, middle class, you could be wealthy. This can be ordered, this data here. Okay, so it is qualitative, but it's ordinal. So we're seeing some examples of ordinal data that can be qualitative as well. Here's some other examples. I'll let you read these. Letter grades on an English essay, A, B, C, D, F. This can be ordered, right? Top 3 flavors of ice cream. This can be ordered. In fact, it is. So if vanilla is the top flavor of ice cream, then you can order it. It would be number 1. And then if chocolate comes in second, it's ordered. It would occupy the second position, and so on and so forth. Okay. So any ordered listing is going to be ordinal. All right, so looking at the next level of measurement, interval. So this is where not only can the data be ordered, but you can also subtract 2 data values, and that difference can be meaningful. Okay, let's see. But there's still not going to be an inherent 0. So here's some examples. Temperature. So if it's 50 degrees one day and 40 degrees the next, you can subtract those 2. You can say 50 minus 40 is 10 degrees. So you can say it's 10 degrees warmer today than it was yesterday. And you could also put those in order, right? You say 50 degrees is the hottest day, 40 degrees is the second warmest, etc. Let's see, calendar years. Okay, so just years. So the years in which a person was born, that is data at the interval level. Because you can subtract that. If somebody was born in 2000 and somebody was born in 1990, you can say the difference there is 10 years. You can say that one person is 10 years older than the other person. And then pain level. Here's another example. So when you list your pain level, that can be ordered, and you can also subtract those, okay, and there'll be meaningful difference there. And like I was talking about earlier, we're talking about temperature. A reading of 0 degrees Celsius, that doesn't represent a condition in which there's no heat, okay? And that's what temperature is measuring, is the amount of heat in the air. Even guys, The coldest temperature on Earth, you know, I don't know what it is. My guess would be, I don't know, maybe negative 100 degrees Fahrenheit. Maybe a little bit colder at times. But even at that temperature, there is heat in the air. All right. And then the last one, or the most complex level of measurement, is this one right here, ratio. So it retains all the characteristics of data at the interval level of measurement with one extra thing. And that extra thing is that it has an inherent zero. And that inherent zero, guys, is basically like a reference point. And because it has that inherent zero, or that reference point, then we can talk about multiples. Okay? So it says a ratio of two data entries can be formed such that one data entry can meaningfully be expressed as a multiple of another. So I'll give you an example of this, like a person's age. So if a person has an age of 0, it's like, well, they don't exist. They haven't lived any, right? But if somebody's 20 years old and another person is 10 years old, the ratio there between 20 and 10 is significant. It makes sense. You can say that the person that's 20 years old is twice, 2 times as old as the person that's 10, okay? And then, of course, the differences in data are meaningful as well. 20 minus 10 is 10 years. So you could say the older person's 10 years older than the younger person, okay? So the key here is that it has an inherent zero, and because it has an inherent zero, you can express one data entry as a multiple of another. Another example would be household income. If one household has an income of $150,000 annually, and another household has an income of just $50,000 annually, you can express those two as a ratio. You can say that one household, its income is 3 times as much as that other household, okay? And again, there's an inherent zero, because a value of 0 would mean no income, a lack of money, essentially. All right. So let's look at a few examples, and then we'll try some on our own. So income, yeah, so a person that has no job makes 0 money, okay? So income is at the ratio level of measurement. So this implies that there's an inherent 0 there. Age, it's kind of coincidental, because I haven't really read these notes. I made them, but it's been a long time, so don't really remember them. But it's a bit of coincidence that I actually picked out these same 2 numbers. So there's a multiple of 2, so age is at the ratio level. Precipitation is another example. Okay, if one location gets 0 inches of rain for the day, that 0 implies no rain, a lack of rainfall. And then, if one place received 6 inches of rain, another place received only 2 inches, you could say that the place that received 6 inches received 3 times as much rain as the place that only received 2 inches. Okay. Some other examples of data at the ratio level would be years of work experience, commuting times, distance to a parking lot. So this would be in whatever unit is used to measure that distance. Okay, it can be feet, it can be meters. Hopefully it's not miles. The number of patients seen by a doctor, measurements on a ruler, scores on an exam, wages, weight, height, changes in stock prices. Okay, so there's a lot of them. All right. And here's a little table that you guys can reference. So you can see here that at the nominal level of measurement, really the only thing you can do is put the data in categories. You can't really order it, you can't really subtract it. And then at the ordinal level of measurement, you can put the data in categories and you can also order it, put it in order, but you can't subtract it, or there is no inherent zero, so you can't express one data entry as a multiple of another. And then at the interval level of measurement, you put it in a category, you can order it, and you can subtract it. And then finally, at the ratio level, it satisfies all of these conditions. Okay. So this table kind of shows you how those levels of measurement become successively more complex. All right. Guys, I would have broken this one up into a couple, but the subsections here were not really given to that. So we're just going to go ahead and knock it out in one video. Okay, so example 2, what we want to do is determine the level of measurement of each of the following data sets. So number 1, the years that a television show on ABC won the Emmy for Best Comedy Series. So the data is right here. So 1955, there's a television show on ABC that won for Best Comedy Series. And then 1979, 1980, 1981. I am going to say that this is interval. This is data at the interval level of measurement, because we can subtract it and we can see meaningful differences here. Okay. Hold on just a minute. Okay. Number 2, the top 10 business schools in the U.S. for a recent year according to Forbes. Okay, so the data here, guys, the data is qualitative as opposed to the data in the previous example that was quantitative. So it's qualitative data. So by knowing that it's qualitative, that would narrow this down to it either being nominal or ordinal. If you look back up here at the chart, okay, it can only be, well, it doesn't really say that in this chart, but anyway. But the data can be ordered, okay? And that's actually what this data is. It's data that's ordered, right? Because it's the top 10 business schools. So apparently, by rank, Stanford is number 1. And then you've got Harvard, and you've got Northwestern. It gives some of the names of those business schools. I think for Harvard, it's Sloan. And I can't remember what it is for Stanford, but anyway. Or no, it's MIT, that's right. MIT, their business school is the Sloan Business School. But anyway, this data can be ordered, okay? So that makes it ordinal. But we can't subtract this data. Like you can't say, okay, Harvard minus Stanford equals something, and then that something be significant. It doesn't even make sense. Number 3. Guys, by the way, pause these videos if you need to. Okay, you can listen to these as you're working on your homework. These examples are going to be very similar to the homework problems that you have. Number 3, the flight numbers of 21 departing flights from Chicago O'Hare International Airport. Okay, now this data appears to be numerical. Well, it is numerical. So you may think, oh, okay, well, this is quantitative data. But it's not. It's actually qualitative. Because these numbers are strictly for labeling those flights. That's it. Okay? So this is qualitative data, so it can only either be nominal or ordinal. Well, you can't really put these in order, guys. Now, I know numerically you could put them in order. You could say, oh, okay, 7,664 is the biggest. So what does that mean? That doesn't mean that flight is the best flight, okay? So yes, you could put these in order, but there's no meaning there. Okay, it's not like when we're talking about the best business schools by rank. These are in order by rank, okay? These flight numbers are strictly for designating the flight. These are almost like names for the flights, okay? So that is at the lowest level of measurement. So that is going to be nominal, okay? It's just like if we had all the students' names that were in this course. It's the same thing. They're just labels. Number 4 here, the length in seconds of songs on an album. Okay. Well, think about this. This is quantitative data, first of all. It is definitely interval, okay, because we can subtract these. We can say, oh, okay, well, one song is 282 seconds long, another song is 252 seconds long. That's a difference of 30 seconds. So that makes sense. We can say that this song is 30 seconds longer than this other song. So it's definitely at the interval level. But I think we can go beyond that. I think we can say that this is at the ratio level of measurement. Because if we had, well, I don't know if we'll find one that's exactly double, but you could. So this 228, if you double that, you would get 556. So if there was a song that was 556 seconds long, then you could say that that song was twice as long as this other song. So that means we can express these data entries as ratios. And lastly, there's an inherent zero in this data. Okay? Because if you had a song that was 0 seconds long, that means it has no duration. It's not even a song. Okay? So this is at the most complex level of measurement, which is ratio. All right, got a few more examples. Number 5. I think this one's pretty straightforward, guys, based on that other example. So the top 10 fiction books on the New York Times list of bestsellers, well, it's qualitative data, but it can be ordered. So it is ordinal, the ordinal level of measurement. Number 6. The times of the day when a person checks his or her cell phone. Let's think about this, okay? We can subtract this data. So if you check your cell phone at 8:28 and somebody else checks their cell phone at 10:28, and you could say that they checked their cell phone 2 hours later. So the difference in data is meaningful, so it's definitely at the ordinal. Well, the next question would be, can we express one data entry as a multiple of another? And the answer is really no. These are just basically slots in time, okay, or moments in time. So that there is no inherent zero here. So this is going to be at the interval level of measurement. Okay. And then number 7, which is the last one, it says determine the level of measurement of the data listed on the horizontal and vertical axes in the figure. So let's look at this figure. Let me zoom in a bit. So what is this figure showing us? This is a bar graph, guys. This is a visual display of data. We're going to talk more about this when we get to chapter 2. But this tells us a story. It says motor vehicle fatalities by year. So what we've got on the horizontal axis are different years, calendar years. 2011, 2012, 2013. And the heights of each of these bars correspond to the actual number of fatalities, automobile fatalities for each year, okay? But notice these numbers are in thousands. Not that that's going to make a difference. So the data that we have on the horizontal axis is calendar years. So it is, if you remember, years or calendar years, that is at the interval level, okay? Because we can subtract these, you could say 2015 is 2 years away from 2013, or 2 years later from 2013, okay? But we can't say that 1 year is twice another year. Now on the vertical axis here, the data is the number in thousands of actual accidents, okay? Well, we are measuring the number of accidents. That's at the ratio level, because a value of 0 would represent no accidents. And furthermore, if in 1 year you had 40,000 accidents and in another year you had 20,000 accidents, you could say that 1 year was had double the number of accidents than the other year. Okay, so you can express that as an interval. So this is going to be at the ratio level. Okay. All right, guys. I'm accustomed to asking if you have questions in my live classes. But of course, this isn't live, but take your time on this. Determining the level of measurement of data tends to be a little more difficult for students. Okay, if you have any questions, just email me and I'll help you. So, in any case, I'll see you in the next lecture, 1.3.